Hello, Dr. Ron England here, coming to you from Daytona State College. This is a kind of a part two of an existing lecture where I actually showed you how to create a linked list in JavaScript, and I did that on a JSFiddle. Now, if you're working with linked lists, one of the challenges with linked lists is the challenge of sorting the linked lists. And one of the easiest ways to deal with that sorting problem is to essentially make that linked list sorted from day one, right from the very beginning. So what I'm going to do is I'm going to show you basically the principle behind the insertion sort, but essentially that principle behind the insertion sort is to have it sorted right off the bat. So how do we do that? Well, to make that happen, I'm going to do a couple of things here. One of which other things I'm going to do here is because I don't want this to say node 1 here over and over again, right over here, I would like it to be a random string each time that it comes up. So I'm going to first go ahead and throw in a function that creates a random string in that spot. So this one's going to be a simple cut and paste because this is something that you can pull this right off the internet. There's plenty of functions out there that create a random string. But essentially what this random string does is it has it'll make a random string of any length. Here's the characters that the random string will be created from. And it's simply going to go ahead and use this the random function in here to get the correct substring of the random string. It's relatively straightforward, and you can look at the code, I think, and figure this one out pretty easily. So then what I have to do over here is the value that goes into this would be a random string, would use that function, and the length would be, and we'll just make it 3. So so basically 3-character random string would be what would go in there each time that this actually came up. So if I ran this, I should get, now in this case what I did is I got the actual function, the value here of random string. Notice the value just said, oh, that doesn't work. Now, so you got to think about this. What happened here? Well, simple. I put the value, which should be a string, to be a string, and yes, it is a string. So can I do that? Well, not really. I have to actually have it call that random string function. So let's do this. Because that call needs to be triggered by an event, now I could put an event on load, but that's not really what I want to do. So I'm going to make the value blank. Okay, and what I'm going to do is in this add node, I'm going to start with a simple seed random string. Let's just say AAA, so there's my seed, and if I run this, you'll see that the AAA goes in there. And now what I want to do is when this add node is clicked, it's going to call add node, but now after I actually add the node, what I'd also like to do is I'd like to put a new value in there. So I have to use the document.get element by ID. The ID of this is V, so I'm going to go ahead and put that V in there, and in this case it's the value, and I'm going to call the function random string and make it 3. And now if I run this, when I click on the add node, the AAA is the seed, so that's going to be the first one that actually goes in there. Now if I click add node, the YNU is going to get added to it, then UKA. Okay, so as you can see, each time it adds a random new content to that random node that goes up there. Now remember, you should have looked at the linked list video before you do this, because that's part of the construction of a linked list. What I'm showing is the content of my linked list, each individual node with its pointer to the next node. What is the content? Now I'm going to do one other thing here in my print. I would really like the print to go to the next line. So what I need to do is add a line break there. So now if I run this and I run it again, it's going to put each of the new individual nodes actually down into, so that you can see them in this order here. I think it's going to be easier to see what I'm doing. Now, what I want to do, now that I've got this up and running and I've got a linked list and I've got the nodes, each time I insert a new node, I would really like to insert that node into where it belongs in sorted order. So in other words, it never just inserts to the top or the bottom, it inserts where it belongs. Well, how am I going to do this? Well, the best way to do this is to actually literally add it sorted. Okay, I want it to be where it belongs in the sorted order. So how do I do that? All right, well, I can either modify the add function so that it always goes in sorted, or I can create another function of the linked list called add sorted. Well, since I've got the add function working, let's go ahead and make another function called add sorted. So what I'm going to do is going to go linked list dot prototype, because I'm actually adding on to it, add sorted is equal to a function, and the function is going to get one argument, which is the content, and now all I simply have to do is now add that in. All right, so how are we going to do this? Okay, well, part of what I can do is I can use the add function a little bit here, because if let's say for the case that the head is equal to null, well, I don't have to replicate any of the functionality of the add function. It already deals with that case that the head is null, and if the head is null, there's no nodes in it anyway, so you're just going to add it to the node 1. So so what we're going to do is start off with if this dot head is equal to null, okay, then what we'll do is we are simply going to go ahead and add it right up there at the head. Well, that's simple. This dot add content, and you're done. Return. So we're finished if that's the case. Well, that's obviously the trivial case. We're really going to be more interested in what's going to happen if the head isn't null. We've got to actually have to figure out where it's going to need to go. So let's look at the logic that goes behind this. Well, we know if the head isn't null, so now what we're going to do is we know that we're going to be adding a node, that we're going to have to do it in the add sorted portion. So we can actually go back up here and say, well, what did we do before with the add? Well, we created a new node and we set the node content equal to content. Well, if we're going to add, we're going to do exactly the same thing here too. So we're going to create a new node, and the content is going to be very important. So how would you do this? Well, if you think about this, if we want to add it into a location that is going to be between two nodes, we have to simply add it in the correct location, and we're going to have to figure out where that is. So let's look at the individual cases. So the individual cases would be, we know that there is actually a head, because it would have been returned if there wasn't. So let's first check to see if what would happen if the node that's being added should go before the head. In other words, it's going to be pushed onto the top of the linked list. Well, how would we figure that out? So if content, that's the content that was passed, and I passed it as underscore content, okay, is less than this dot head dot content, that's the content of the current head. Okay, if it's less than that, well, this is the case where I'm going to need to add it before the head. I'm not going to fill in the code right this minute. I am going to come back and fill this in, but this is a situation where we know that it's going to put it before the head, and when it's done, it's going to return. Now, one of the things I like to do here and here also is I'm actually going to return the actual content that was added. So note what I can do here. Remember, I did this call for this add content, and then I returned. I don't have to do that, because by convention, I'd really like to return what was being added. And if I go look at that add function, I'm going to note that the add function always returns the node that was being added. So I can just return this add content there. And I know here I'm also going to return, well, what am I going to return? I'm going to return the node that was being added, so I can just say return node. And actually, reality is each time that you do any of these adds, you're simply going to return the node from this point on that you have created there. So I need to insert here the logic of how to put this node in front of the head. And now, here's the problem. Okay, well, actually, here's the problem, but there's problem's got its own solution. What if the content is greater than the head.content? Well, if it's less than the head.content, that's the first node you're going to check anyway, right? Because that's the first one that's always in the list. So I can quickly figure out a little bit of what I'm going to be able to do here. I'm going to first say, well, the head is no longer the head. Okay, the head is going to need to have its previous pointer point at the node that I just created. So that's pretty easy. So this dot head dot prev is equal to node. Okay, in other words, the current head, its previous pointer is going to point at the node that you just created. Okay, well now we know that, okay, the node that you just created has a next pointer, and it's going to point at the current head. Okay, well that was straightforward. Okay, so, but now I need to make the node the head. Well, now that the pointers are set, making the current node the head is not that bad. So this dot head is equal to node. Okay, I set the pointers first, and then I set the head to be equal to the node that I created, and now I can return it. Okay, well that wasn't too bad. Okay, hope it works, but we'll check to see if there's flaws in the logic as we come around and test it. Now, next situation. Obviously, the next situation is that the content is going to be not less than the head. It's going to be greater than the head, but it should be less than the tail. Otherwise, it's going to get tacked onto the tail. So how do I do that? Well, the first thing that I do is I'm going to say, you know what? I'm going to create another node. Okay, this is the node. The node is the node I'm going to be added, but the I'm going to have to say there, we'll say C for current node is equal to this dot head. All right, so now I have a current node that's equal to the head, and what I want to do is I want to go through each individual node, basically start at the head and work my way through the nodes and figure out where exactly does the node that I'm adding go. Well, if the current node's the head, I can do a while, because the while will be while C node is not equal to null. And actually what I could do is I could actually make it so the next is not equal to null, because the tail will be where the C node dot next is equal to null. And so if I'm at the tail, I know I'm automatically going to tack it on to the tail anyway. So I can kind of use that little bit of logic. The current add always puts it at the end anyway. So if I get through to where the C node dot next is null, that is the tail, and I know here I'm going to need to return the node that I created. I haven't done anything yet, but I know that I'm going to need to return the node that I've created at the end of this. There's going to be some logic that's going to have to go into this section here that I'm going to need to come back and write, but I do know that if it actually gets to the tail, it's gone through all the whole thing, and it's not between any of those nodes, it's going to be tacked onto the end. So I know that I can return this dot add underscore content. Add by default always adds on to the end, and if it makes it to the end, it gets through all the logic, it makes it to the end, it means it's greater than all those nodes. It's going to have to go into the end anyhow. So we know that it's greater than the head, and if it's not less than the tail, which is going to be my logic in here, I'm going to have to create an if that does that. So if content, we know that the content is going to have to be greater than the current node's content. Okay, now, but I'm going to need a second one. It also, and content should be less than, okay, the current node has a pointer to the next node, which has its content. Let's move this over just a tad so I don't have to scrunch to a next line. And so there is the logic. If it's greater than the current node's content and less than the next node's content, this is where it goes. So I need to insert it right there in that spot. Okay? Okay, now the logic of that insertion. How does that work? Well, shouldn't be terribly hard if you think about it. So you've got the node that you just created, okay, which is the new node, and that node's going to have a pointer to the node before it. So node dot previous, okay, is equal to, well, that's going to be pointing at the current node. Okay, so it's going to go out to the current node. So the previous of that's going to have to be equal to that one, which also tells you that the current node dot next is going to have to be pointing at the node. Voila. Well, that was pretty easy. Okay, now what about the next node? Well, node dot next, that's the node you're adding, is going to be equal to cnode dot next. Okay, you're going to point it to, because it's going to go in between. Okay, now here's the problem though. I've already pointed cnode dot next back to the node, and node dot next is now pointing at cnode dot next, but cnode dot next got pointed back to the node. Order matters. Okay, so I know that I'm going to have to do this, but I'm going to have to do this after I actually set the node.next equal to the cnode.next. Okay, in other words, that node's going to get inserted. It's going to have to be pointing to the current node. So the current node can't change just yet. Now, I can change the current node back to that too. Now, except I've still got a problem here also, because I'm going to also have to change that next node's previous pointer is going to have to point back to the node. Well, now that I've looked at that logic, I kind of know exactly what I need to do here. cnode.next.prev, the pointer, okay, I haven't changed the current node yet. The next node is always going to be the next one. The previous is going to be pointing backwards, and when it points backwards, it's going to have to point at the current node. So now it's going to be equal to node, and cnode.next itself is going to be equal to node. And so essentially what I've done here is I've inserted the node. And after that is all said and done, we return a node. And then we return this. Now, how do I actually make this whole thing work? Well, this becomes very simple because I've already got the existing code that adds. But now all I'm going to do is I'm going to go over here, and when I create this thing, instead of adding, okay, I'm going to add sorted. Voila. Okay, instead of adding, I'm just going to add sorted. Now let's run it. Now, if I didn't break anything, okay, which I did, that happens. You do break things. Okay, that's not only normal, it's common. Okay, well, I probably have a mistake in here somewhere. Well, right off the bat, I can see that I need an extra parenthesis right there. Okay, I've got two there, one there, which goes down to here. Well, that's not going to work. And I've got one here that goes with that one, but I don't have anything that goes with that one. Actually, it's even red. I've got to come over here, and I need to put a parenthesis in. Well, hopefully that'll fix it. Okay, okay, that adds that one. GVS went where it goes. MFB should be after that one. Okay, whoops, it missed one of them. It didn't add it to the thing. So YEE. Okay, now this is where debugging becomes very important, because there's a logic flaw in here, but the logic flaw should be traceable from what the code is doing. So S9D. If you look at what's actually in this, and we can trust that this is printing out the nodes in the list in the correct order. S9D should go in after GVS. Those two are actually in order, and nothing happens. Now, LEU, okay, that's going to go to the end. Let's find one that's actually going to go in between. Okay, okay. Well, nothing is getting added at this point. Well, something is wrong in my logic if nothing is being added. But what did happen was, and let's run again, what did occur? When I clicked AAA, it added. So the content, the trivial content of the content being less than, well, first it being, the head being null, that worked. So that worked. Now, we've got a number of ways that we can trace this. Now, if I add ZWP, okay, well, that one there, which should have been the situation where it actually adds here. In other words, the content was not less than head.content. Okay, it was greater than. So now it should have gone into here. And if you look at this, it should become very obvious what the problem was. If you look at it, what did I do? I never incremented the node to the next node. So cnode is equal to cnode.next. Well, except there's a problem there. I should increment the current node to the next node. But wait, I changed the current node, right? Okay, in other words, it had no way to move to the next node to find out, except that, very simple, it will never need to go to the next node if it was inserted anyway. Make sense? So really, I want to put that cnode equals cnode.next there outside of the if statement, because the if statement is if you actually insert and then go to return. The logic was it was inserting right off the bat. Okay, and if the content was less than the head, it would have inserted because it got to that point. But here, when I was actually trying to insert it between two nodes, it didn't do that. So now it's run. Okay, and now I'm going to add, I'm going to add, I'm going to add, I'm going to add, and again, we're not seeing anything occur here. Now, okay, so now you saw that things were happening, and it did actually go to that next one. So what's actually happening in this case? Well, this is where you really want to get into the concept of debugging. And what I'm going to do here, because it's actually a little bit easier, I'm going to go ahead and update this and set this as a base here, because what I'm going to do is I'm going to pull up Chrome. And it's going to be kind of hard to see Chrome here, but I'm going to pull up Chrome. And what I'm doing is I'm actually running this in two separate different browsers here. And this is important, because this is how you're going to determine the logic flaws that you might have in your design. And you will have situations where you've got little logic flaws. Even if you know where the logic flaws are, well, even if I know where the logic flaws are, it doesn't do you any good for me to just say, here it is, and solve it. So what I'm going to have to do is show how do you find them. Well, part of what's going to have to happen is I got to know what's happening when I go into this. Now, there's a few ways when I go into this piece of code right here, because here's where the problem is occurring. If I hit run, and I got AAA, and then I add another one, and I add another one, and now after that second one, nothing's actually occurring. Why isn't it actually inserting these things in the list, or why am I not seeing them? Now, before I do this, okay, I would normally, I would normally go ahead and look at this and say, let's step through the logic. Okay? That's important. I would step through the logic to make sure that in my head it makes sense, because maybe I had a flaw when I was pointing it out to you, but I would like to fix that. That's great in this simple logic situation, but it's not great if you're trying to do a situation that's a little bit more complex. So what I'm going to do here is I'm going to bring up the developer tools. And one of the challenges of using Fiddle when you're doing this is if I set a breakpoint in here, that breakpoint does not necessarily always come out. When I'm in JSFiddle, it sometimes moves the breakpoint. But the reality is I want to see what's happening. So this is a great spot to put a breakpoint. And I could potentially put a watch here. I've got a couple watches in there already. But let's run this and let's see. And boy, this is really hard to do because I don't have a lot of screen to work with here. But let's run this and see first if I trigger the breakpoint. Okay, add. Okay, I'm not getting to a pause here because the breakpoint itself is not actually 94, and that is that's because I have experience trying to do debugging in JSFiddle in Chrome with the Chrome debugger, and the reality is that I've learned that when I set these breakpoints and I set it to line 94, in the actual final running version, the line that you're getting is not necessarily line 94. It actually is another location. But what I did do is I did set a breakpoint. So what I'm going to have to do is I'm going to have to find the spot where the breakpoint actually needs to occur. So I may actually be in line 128. But I'm going to actually jump offline for a second, find that correct line by just trial and error, and then come back with it. Okay, so hang on. Okay, I'm back, and the lines that I wanted to breakpoint were lines 91 and 94. So now that I found the lines that I wanted to breakpoint, and essentially, if you bring up the browser and go to sources, and then down here you're going to see a list of the JavaScript pieces that you have, but index will be the one that you want. And if you're doing this in a web page, it's going to come up to the right location, but here it's trickier. So I put a breakpoint at line 91 and 94. So now if I run this whole thing, it's paused. Oh, I had a breakpoint at 49. I don't want that one. Okay, so let's bring that one out of there. So I hit add node, and it adds. It never got to any of the breakpoints I had because it's the trivial case. Now if I click add, now the point here is not the logic. I'm going to let you solve the logic. The point here is the debugging. At 91, I've got some information that I can do, and I am in the Chrome debugger. Current node, if I go over it, well, it's currently undefined. This.head is not, however, not undefined, and you actually got some information about the node. Okay, if I unpause the debugger, I click resume, which is an F8. Okay, it's going to go through and it's going to add the information that I had right there. Okay, if I hit add node again, okay, that one actually was a case where it didn't trip it because the content was less. Let's hit it again. Okay, now this time it actually got to here. Okay, and if I go here to the head. Okay, the head is 069, which actually is what you expect it to be, and there's the next, okay, which is next is a node, which is YCH, okay, which is previous is AAA. So Here's how you solve the logic. Okay? And this is an expectation. In the debugger, you look at this and make sure that that everything that you've got set here makes sense. The node that is the head should have a node labeled next, which should have a node that is the next node with the content AAA, which also has a next and a previous. The previous should have the content of 069. It points backwards. The next one should point at the next node, which is YCH. Okay, the current logic here is that you're going to take 4EP, which is the node that you're adding, and it should go between the 069 and the AAA. Now, okay, I just want to go one step forward to see if this is actually occurring. Okay, how do I do that? To do that, you need to step forward. You're going to step into. Okay, so you step into the next function call. Boom. Notice that the blue went one line further. CNode.next is AAA. It's not null. I can go to the next line. Okay, now CNode content, 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 CNode next content. Okay, logic says it should go in between there, step. There you go. Now I am looking as I go through each individual line of the code, and voila, I am now able to determine if my logic is working or my logic is not, because I'm specifically looking at the values that you have in each of these. Now, this has already gotten to be a very long video, longer than I wanted to do, but I think that I've made the point of how do you do an insertion sort. I'm not going to take you through the fix by the way. I've already fixed the logic. That's why it's working, but you need to be able to fix the logic that goes with this. It's not hard to do, but you need to know the steps to allow you to determine, because you're always going to find logic issues. You're always going to have to do things like this. Now you have the tools to make that occur. You've learned. Now, as a recap, we've taken a linked list that had an add function in a regular doubly linked list. We modified the add so that it will now add sorted, and I looked at the individual cases of how you would actually, is it less than the head, is it greater than the head, where does it fit, and then I had an introduced logic flaw, which I then needed some debugging tools to figure out how to solve by looking at the values as I work my way through the algorithm. I've shown you how to bring up the Chrome debugger, look at the actual breakpoints, and bring up the values of the individual nodes, allowing you to debug what you've done. Hopefully this will get you out there and working on this hard. Good programming. Thank you very much. I think this is specifically designed for my students in data structures, but I think this is also going to probably be used for other people as they're trying to do debugging and solving these algorithmic problems. Thank you very much. Good programming.